Hello students, welcome to the fourth screencast. You guys know how this works by now, so let's get to it. Here's the problem. The ratio of the length of a soccer field to the width of the field is 3:2. A scale drawing of the soccer field has a scale of 1 inch for every 20 yards. The length of the field in the drawing is 6 inches. What is the actual width of the field? Alright, so this is one of those two-part proportion problems, but we can do it. First and foremost, notice that it said the ratio of the length of a soccer field to the width of the field is 3:2. That tells us a lot. Notice that they did mention the word length first and then width. So therefore, the 3, which was mentioned first, 3:2, represents the length. Alright, so let's label that so we don't forget. And then 2, of course, would be the width. And it helps to always draw a picture, which you can see to the right. There is one. So the 3:2 is going to help us there. Now a scale drawing of the soccer field has a scale of 1 inch for every 20 yards, which means on the map, on the field, on the drawing, 1 little inch that you measure represents 20 yards in real life, if you recall. That's why we have a scale there, because everything is proportion. The scale has to be in proportion to the actual physical object that it is representing, in this case, the soccer field. But the length of the field in the drawing is 6 inches. So let's label that here. We know that this is 6 inches. What's the actual width of the field in real life? Alright, so first thing what we have to do is we know that for every 1 inch, that represents 20 yards. That, ladies and gentlemen, is where we start. We start with the 1 inch for every 20 yards, and we need to make that equal to some other ratio. Now notice the other information that they gave us. The length of the field in the drawing is 6 inches. The length of the field in the drawing is 6 inches. Alright, so the inches unit has to match up with the inches unit on the scale. So therefore 6 inches must be in the numerator. Because notice that 1 inch is the numerator, and so therefore the other inch, in this case 6, must be in the numerator, which means we are solving for some x number of yards in the denominator. Inches, yards. The 1 and the 6 represent the inches, the 20 and the x represent the yards. Well, the nice thing about a scale is there's always a numerator of 1, so therefore it's pretty simple cross multiplication. 6 times 20, 120. 1 times x, that's very simple, of course, x, or 1x. So therefore we know if the drawing has a length of 6 inches, the actual length of the field is yards. That's right. 120 is not the answer. Remember, we just calculated the length. We did not calculate the width. We know this because the length of the field in the drawing is 6 inches. Thus, we represented the length of the field in real life. So if you stop here, you're not quite answering the question. Here's where the second part comes in. The question asks, what is the actual width of the field? Width of the field. Now, we just calculated the actual length of the field. Well, now we have to go back to this 3:2 ratio between the length and the width. So, we have to use 120, yes. But once again, let's start with 3/2, noticing that 3 represents the length and 2 represents the width. Now what are we calculating? We're calculating the width, knowing that we just calculated the length. So which number, the 3 or the 2, represented the length? As you can see right here, as we labeled it earlier, it was the 3. So therefore the 120 must go in the numerator, because we are calculating for the width, x, which is the denominator. Again, once again, 2 is the width. So the width down here, the length up here. And then we have to simply cross multiply. 2 times 120, 240. 3 times x, it's not so bad, 3x. And then, of course, to continue our calculations simply means to divide both sides by 3. And 240, well, if you can do 24 divided by 3, you can do 240 divided by 3. 24 divided by 3 is 8, so 240 divided by 3 is, of course, 80. Is x in this case. Now, you could have used x, y, z. It doesn't matter your variable that you used. But we just figured out that the Length of the field is 120 yards in real life, based on the information they gave us. And we just discovered that the width of the field is 80 yards in real life. Now, does that represent a ratio of 3 to 2? Well, we can always check that by taking what we think the length is. We just calculated it to be 120 over the width, which is 80. And if we were to reduce 120 over 80, yeah, we would definitely get 3 to 2. Wonderful. Of course, by using a factor of 40. 120 divided by 40. 80 divided by 40. And we know we got it right. So once again, ladies and gentlemen, the width is 80 yards. All right. You are going to do your problem here. Here's the problem. A typical National Football League game, NFL of course, the ratio of females to males in attendance is 2 to 3. Okay, so that's a little similar. Estimate the number of male and female spectators at a game that has 75,000 spectators. That's a lot of people in attendance, 75,000. Once again, just to kick you off on the right foot, 2 to 3 is your ratio of females to males in attendance. Thus, the 2 represents the females because it was mentioned first. And the 3, of course, represents the males. Now, this is another 2-part problem that you need to figure out. Knowing that there's 75,000 people in attendance, how would you use the 2 to 3 ratio to estimate, to calculate the number of male and female spectators? Remember, the question is male and female spectators. Now, here's a hint. Of course, both numbers added together have to equal 75,000. All right, so you know how to respond to this. I want to see your work. I want to hear your explanations. I want to see your explanations in one way or another. Good luck. Email if you have any questions.